All right, back to our worksheet again. I'm excited because this is one of my favorite questions because we get to answer the question about that combination lock. So how many possible 3-number combinations are there for a combination lock? It has 40 numbers on its face where none of the 3 numbers can match. So if you picture what we're talking about one of those locks that is like this, and then it's got that spinny dial on the front. And so on the front there'd be the numbers 1 through 40. And it's the one where like you turn it one way first and you go to the number and then you spin it back the other way and go to the next number and so on and so forth. So one of the restrictions for coming up with the code is you can't use the same number a second time. So if at any point during the code I have a 10, I can't have another 10 in the code. So what we need to think about is can we break this event, this question down into smaller events, into a sequence of events. And if we think about it, it's really quite similar to the zip code question then, because my combination is going to have 3 numbers in it, right? I have my first number, second number, and my third number. Think about what you want in the end, right? The final thing we should be counting is codes, is different combinations that we could put into the lock, which are all strings of 3 numbers. So that's how I can break this down into those pieces. Now, if we think about what those numbers can be, well, for the first number, we've got 40 different options, right? There are 40 numbers on the face of the dial. So whether that's the numbers 1 through 40 or 0 through 39 or even just something else entirely, in total there are 40 of them. So if we think about how many options we have for the first number, all 40 of those would be options. When we get to the second number though, let's think about what we said. We can't repeat. Right? I can't have any matching numbers. So if I think about what that number, how many options there are, well, my original pool was 40 numbers and I picked one of them. I don't know which one I picked, but I picked one of them, and that number that got picked is now out of the pool, right? Whatever number I picked for my first digit of my code, my first number in my code, is not an option anymore. So we're down now to just 39 options. That number decreased because I can't repeat. It's kind of like in the first example where we had the activities question, the first one on our worksheet, where once I had picked one of the activities, I couldn't pick that activity again, so the number of options decreased. Now again, when I get to the third number, again I can't repeat. But now if I think about it from that original pool of 40, we've taken away 1 and then another 1. So now there's 2 things missing from the pool. So now we're down to 38. I can't repeat either of the original first numbers. So hopefully you had already tried this one and we kind of can get a feel for how to start to do this. So 40 for the first option, 39 for the second, 38 for the third, and then sequential counting principle says multiply those numbers together to get the total number of options. So if we pull up our calculator, we'd have 40 times 39 times 38 is 59,280. 59,280. Which is a lot of possible combinations. That's why it's really hard to just pick it at random by guessing the numbers that someone picked.